Hello everyone, welcome to the DS Masterclass. In today's tutorial, we are going to discuss about the design and simulation of RC phase shift oscillator. So for that, we create a new project, RC phase shift oscillator. Can give any name and create a blank project. Okay. So for this RC phase shift oscillator, we are in need for RC ladder network that has to be connected in feedback so that the RC ladder will give you the additional phase shift so as to satisfy the Barkasian criterion in order to produce sustained oscillation. And we are going to implement the RC phase shift oscillator with the help of operational amplifier. So for that, I'm going to place components one by one. So let me take the operational amplifier, place it, and press escape. And for this, we are in need for resistance. One resistor should be placed at feedback path and three resistors has to be placed at RC ladder network. So, and let me rotate this resistance. I can place it here and one more I can place it here. Yes. And then we have to place the capacitor. So capacitor, I'm going to place three capacitors. And the last one capacitor. Let me connect all these components using wire. So the rear end of the capacitor has to be connected to output terminal, which serves the feedback for the RC ladder network. Okay. And then the feedback resistance has to be connected with the output terminal. And the another end of the feedback resistance has to be connected with the RC ladder network. And let me connect all components of the ladder network. That's it. And then we need to connect another input terminal of operational amplifier to the ground. Okay, now I'm going to place the ground terminal. So here you should have ground and the two resistance has to be connected to the ground. And now we have to set the component value of the components. So I'm going to use 100 nanofarad for the capacitance, so all three capacitance. C3, C2, and C1. And the feedback resistance, I'm going to set it as 290K. And all other remaining resistance has to be set it to 10K. Now the circuit is ready for simulation. So before that, we have to create a netlist. So netlist has been created successfully. And now we can create a new simulation profile. So you give the name for new simulation profile. Now the simulation is, so we are going to take the transient analysis. So for that we have to enter the run time. So I'm going to run the circuit for 50 milliseconds. And I'm not going to take the reading from zero. I'm going to take the reading starting of the waveform at 20 milliseconds and the maximum step size of 0.1 millisecond. So apply all these settings. Instead of ms, it's enough to have m. So apply. Oh. So now we can place the voltage marker at the output. So now we can run this simulation. So instead of sine wave, we are having one straight line, horizontal line. See, this is because non-availability of initial condition at the capacitor, which is at input terminal. So you just shift to the circuit. See here, this capacitor has to be provided with a certain initial voltage. So let me set it as minimum voltage of 0.1. See here, initial condition now. So here you have to give 0.1 volts. Least possible value we can give. So after that, now you run this circuit. Now we are getting the sine. So only when you give the initial condition of the capacitance, capacitor, and not all the capacitor which is see from here, from this capacitor, the voltage or the input voltage is fed to the input terminal of the operational amplifier. So that this capacitor alone has to be provided with minimum initial condition voltage. So that only after giving initial condition, we receive this assignment. Okay. Thanks for watching. If you have any queries, you kindly post it in the chat box. Thank you. Thank you all.